This is how an angel does. Blame it on my own surprise. Blame it on my ADD, baby.
Within this project, we utilize the change momentum, or otherwise known as impulse. The impulse exerted by John on the hovercraft is translated into the mass of the hovercraft, giving it initial velocity. The impulse equation, F delta T equals m delta v, which in other words is force times change in time equals mass times change in velocity.
In our hovercraft experiment, we used a piece of plywood, some plastic wrap, and an electric leaf blower to create a nearly frictionless craft that can withstand and hover a 200-pound man, also known as my dad. Air flows through 6 holes in the plastic surrounding a paint can lid fastened through the plastic into the plywood, creating a donut effect that can withstand an impressive amount of weight hovering over a smooth surface. We enabled our hovercrafts to achieve elastic collisions using foam pool noodles to surround the edges of the hovercraft to create an elastic effect when it hits something, say, another elastic hovercraft. Because momentum is always conserved and the collision is elastic, we are able to use the equation m1 times v1 initial plus m2 times v2 initial equals m1 times v1 final plus m2 times v2 final. In our experiment, we had two elastic hovercrafts. We had one hovercraft going at a constant initial velocity and the second hovercraft initially at rest. We know that both masses are roughly the same. Now, when we hit, momentum from the first hovercraft is transferred into the static hovercraft having the same weight. And because the hovercrafts are the same weight, the first hovercraft after the collision should have a velocity of 0, and the second hovercraft should now be moving just as fast as the first hovercraft's initial velocity. Now we know that because the initial velocity of the second hovercraft is 0 and the final velocity of the first hovercraft becomes 0, the values in which they are incorporated should be 0. Now we are left with m1 v1 initial equals m2 v2 final. Because the masses are equal, they cancel out, and now you're left with v1 initial equals v2 final, which shows that momentum is conserved and transferred from the first hovercraft to the second hovercraft. Fun facts about momentum. Throughout the school year in AP Physics, we've learned that momentum equals mass times velocity. But that's not necessarily true, because it is no longer accurate for objects moving near the speed of light or light itself. Momentum actually equals the mass times the velocity divided by the square root of 1 minus the velocity squared over the speed of light squared. Because almost all velocities are small compared to the speed of light, the velocity squared over the speed of light squared is essentially 0. And when you plug it back into the equation, 1 minus 0 is 1 and the square root of 1 is 1. So therefore momentum equals around the mass times velocity divided by 1, which is mass times velocity.
No point in telling me I'm wasting time today. Lose change if you know the things I know. Every little bit of it I hit when I'm not at home. Home, such a funny little life. Everybody thinks now that I ought to rock. Not true if you know what's best for you. Shut my eyes down now, can I get a deep